Hi, this video is going to introduce you to dihedral angles. We've already talked about the line separation postulate this year, which says that a point separates a line into three distinct disjoint sets, the point and the two half lines. And then we also talked about the two-dimensional version of that, which is the plane separation postulate. That says that a line separates a plane into three distinct disjoint sets, the line and the two half planes. And now we're going to look at three dimensions. So it's called the space separation postulate. And it says that every plane separates space into three distinct disjoint sets, the plane and the two half planes. So imagine, if you would, our math room and the classroom next to us, the Spanish room, and then the wall that has the whiteboard on it would be the plane that separates space into those two rooms, those two disjoint sets, those rooms that are each considered a half space with the wall in the middle. The plane, which in my example would be the wall, would be called the face of the half space. And each of the half spaces is convex because any 2 points in the half space, the segment joining them would be in the half space too, which just means if I take 2 points in the math room and connect them, I will still be in the math room. Now we know in two dimensions, when I have two lines that intersect, they intersect at a point and they form four angles. These two angles, which are of the same size, and these two angles, which are also of the same size. Now let's look at that in three dimensions. When we have two planes that intersect, they are going to intersect at a line and form four angles that are called dihedral angles. So here's my line, and remember that lines go on in both directions forever. So I've got my line there that acts as the edge of my angle. And now the notation needs to be a little bit different, because I need to show that there is a line for the center, not just a point. So this is important. When you notate a dihedral angle, you need to list a point in one half plane, a point in the other half plane, and then 2 points on the line that acts as their edge. So for this particular angle, I would have angle P, MN, R. So here are the official definitions. A dihedral angle is the union of any line and two half planes that have the line as the common edge. So I can color this as the half plane, and then here's the other half plane, and then the line that's in between them is called the edge of the angle. And the face of a dihedral angle is the union of, so let's say, this half plane together with the edge. That would be considered the face of a dihedral angle. The interior of a dihedral angle is the infinite wedge formed by the intersection of the two planes. So that would be this area in here. Now, in order to measure a dihedral angle, we have to measure the plane angle. And the plane angle is formed when you take two rays that are perpendicular to the edge of the dihedral angle. So you notice how this is a right angle, and then if you can see this one as well, it's a right angle. So if I want to measure angle LPQM, that's the dihedral angle, then I would have to measure that plane angle. So a dihedral angle is kind of like the 2 pages of a book connected with the binding. The binding would be the edge, and the 2 pages in the book would each be the half planes. I know it can sometimes be kind of hard to visualize three-dimensional space when it's drawn on a two-dimensional surface, but just do the best that you can.